Okay, lesson 15, factor by grouping. The goal for this lesson, you're going to factor by grouping. So we've talked about how to factor. Factoring is breaking things apart. So we've learned how to multiply things together in Algebra 1, and then you kind of learn how to factor or break things apart in Algebra 1, but we're doing more advanced stuff in Algebra 2. Okay? And all of these lessons are basic to Algebra 2. Okay, so because we're going to use what we're learning now for later. So you kind of have to know what you're doing from this point on and be good at it, okay? Otherwise you're going to struggle through the rest of the class. So when we factor by grouping, it's kind of like we're looking for patterns in numbers, and we're trying to break a code, and we're kind of moving things around to make it like easier to break apart, okay? So it's kind of like you're going to break a code, breaking a puzzle, so finding similarities between numbers, okay? And that's just something we do in real life. Like you might be like maybe you're a forensic scientist one day, meaning you might work for the FBI, and you're like trying to figure out, how do I solve this murder mystery, okay? So you're finding common factors between different elements at the crime scene, finding common factors of evidence, okay? So you're learning this logic, okay? So this isn't just about math. This is about logic and finding common factors. Okay, here we go. So these are the steps. Those were the steps. What's going on? No? It's not moving. Oh, it is going. There we go. Okay, these are the steps. Sorry about that. If you're on the video, pause it now. Here we go, numbers 1 and 2. Okay, 1 and 2. Now, these problems look a little crazy, right? So when you have a problem like this, can we do x box? No, because it's not quadratic. It's not a quadratic equation. This is actually cubic because the biggest exponent is 3. Okay, but it still says factor completely, so which means I might be able to break it apart. Sometimes you can't, but sometimes you can. So what I do when I do this kind of problem is I'm looking at the coefficients. We have 14, 12, 7, and 6, okay? And I'm looking for common numbers, like common factors. 14 and 12 have a common factor of 2. 2, okay? 14 and 12, right? 7 and 6 don't have a common factor, right? So that's not good. But if I take a step back and I'm like, okay, what about 14 and 7? What's a common factor between 14 and 7? 7, right? So that's even bigger than 2, right? And then if I were to group these two together, and let's look at 12 and 6. What's the common factor? 6. So they both, if we just change things around a little bit, group them differently, we can factor them. Okay, so we're going to regroup things. So I'm going to use the commutative property. And we're going to start with 14. K cubed. And we wanted to bring that 7k, right? We're bringing that down here. Plus 12k squared plus 6, okay? So now they're just changed the order. We didn't change the meaning of this at all. It's still the same equation. It's just a different order, or same expression, okay? Now we're going to group them with parentheses. So watch up here. We're grouping these together and these together, okay? This is a really important part. Once I group them, watch what I do. I'm going to add a plus sign in the middle, okay? You're not changing anything. We're just plus, plus. Does that change anything when I put a plus sign? No. Okay? All right? So now they're grouped together. Now we're looking at this term. How can I factor this out? 14k cubed plus 7k. What's the common factor between both of these? 7k. Good. So just like that from earlier this week, GCF 7k. Then I have 7k times 2k squared is equal to 14k cubed. 7k times positive 1 is equal to 7k. You follow me? Okay. Next one. What can I factor out of these two? 6, right? So we still have a plus sign here. So we put plus 6, right? Positive 6. So we know positive 6 times 2k squared plus 1 is our second term. It's going to be equal to that. Do y'all see that? Yes. Now, at this point, you need to see a similarity between these two terms, right? What do you notice that's similar in both of these? 2k squared plus 1, right? So that means you're doing it correctly. So that means in both of these terms, I could still factor out this one term, 2k squared plus 1. Just listen right now, okay? So what I'm going to do is I'm going to factor out 2k squared plus 1 from these. So I know 2k squared plus 1 times 7k is the first one. And then 2k squared plus 1 times positive 6 is the second one. And then I put parentheses around this because we know we're multiplying this to get these two terms. And then that's it. We're done. That's how we do number 1. Okay, question on number 1? That's it. So it's a little weird in the sense that you have a little bit of a process, but the process is the same when we factor by grouping, okay? Watch it happen one more time. Look up here. I'm going to replay it. So the first thing I'm doing is finding similarities in the coefficients. The similarities are 14 and 7 have a GCF of 7, and 12 and 6 have a GCF of 6. Okay, so I'm regrouping, putting parentheses, and then putting specifically a plus sign right here. Y'all see that? Then we got, out of this one, we could factor out 7k. Then when we do that, we get this factor. We could factor out a 6 here. We get this factor. Both of these we're checking. Are these both the same? Yes. So now we go here. We could factor out these 2k squared plus 1 in its own parentheses, and then we multiply it. Okay? Watch me do number 2. Just like number 1. All eyes up here. Eyes up here. Okay? Number 2.
You don't have to find the factoring. It doesn't have to be the same, right? It could be different.
The
factor.
Factoring what? What are you talking about specifically?
Like, you know, there's 7k in parentheses, 2k squared plus 1 on each.
Uh-huh.
Is it always going to be the same?
Yes, it needs to. That's a good question. These two need to be the same. What happens if these are not the same?
And you did it wrong.
You could have done it wrong, or you can't factor it.
Can't factor.
Does that make sense?
Yeah.
So great question. Okay, so what happens if these are not the same? You may have done it wrong, so start over, or you just can't factor it, okay? And that happens. Sometimes we can't break things apart. Okay, anyways, number 2. Okay, looking at my coefficients, we have 24, 21, 64, and 56, okay? We know that 24 and 21 have a common factor of 3, okay? That's okay. And then 64 and 56 have a common factor of 8. Okay, so do we want to switch these apart? Well, let's look a little bit differently. What about 24 and 64? What's a common factor? 8. Okay, what's a common factor between 21 and 56? 7. So that's better, okay? Because the first time it was only 3 and 8. This regrouping would give me 7 and 8, right? Greatest common factor, yes? Following me? So here we go. Now we're going to factor out A. We're just going to regroup now. 24x cubed. And we're going to put the negative 64x next to it. On this example, we have to move it. Not all the time you have to move the numbers. Plus 21x squared minus 56. Okay? Then we're grouping them together, grouping each of these together. And then what has to go between them for sure at this point? A plus sign, okay? Sometimes this right here in the middle in front of the 21 might be a minus sign, okay? Sometimes this is minus, so you leave that alone, but you still have a plus in the middle. In this case, there's still a plus, so, okay? First term, I'm going to factor out an 8x. So this could be 3x squared minus 8, okay? The second term, I'm going to factor out a positive, positive 7. So we got 3x squared minus 8, okay? And that's it. Now at this point we're noticing, okay, there's a common factor of 3x squared minus 8. I'm going to factor that out. So we got 3x squared minus 8, factoring that out. And then you just take the coefficients of each, you go 8x plus 7. And then you're all done. It really isn't too hard. And then you're done. Okay? Same process. Now, just like Yusuf said, if you don't have the common factor, then stop, go back, double check your work. Maybe you didn't group correctly. But you should have the same or you should have similar factors, okay? Make sense?
Would it still work if you would have took the 3 out of 24 and 21?
Yes, just...
Well, not necessarily. It wouldn't have worked, no. Yeah. That's a good question. You wouldn't have had a common factor. You would have to factor again. You'll notice that you would have to do an X box, and then it kind of gets messy. So you should try to find it so it looks clean. Okay. Anyways, that is the answer. Okay. So numbers 1 and 2. So before you start writing, I'll give you a moment to write. 1's tell 2's about number 1. 2's talk about number 2. Ready? Set. Talk. Okay, number 3. We're just going to do 3 and 4 on this lesson because I want you to spend more time practicing. I really think you're going to get it, okay? But you just need to practice it. Number 3, let's do this one together. This one we do together. Okay, so let's figure it out. 12 and 21. Let's look at those first two terms. 12 and 21. What's the common factor of 12 and 21? 3, okay. So I know I had 12 and 21 to be 3. Oh, sorry. Okay, and 4 and 7. Is there a common factor between 4 and 7?
You do 12 and 4 and 21 and 7.
So there isn't, so...
And 21 and 7.
Okay, good. So 12 and 4 has a common factor of 4, and 21 and 7 have a common factor of 7, right?
Yes.
So that's better, okay? So let's try that out. It's got 12x cubed, and we're just rewriting this, plus 4x. We're doing this together. Hopefully you're following along with me. Plus 21x squared plus 7. Okay? So now we've rearranged things around. They're not in descending order, but that's okay. And we're going to put parentheses around each of these, right? It's a positive 21. So we're going to put a plus sign in between for sure because it's still a big addition expression, okay? What can I factor out of the first
4.
binomial?
4x.
4x, okay? So I'm taking out 4x. 4x times what is 12x cubed?
3x squared.
3x squared, good. 4x times what is equal to 4x? 1, positive or negative 1? Positive. And I say positive 1 because we're putting plus 1, right? Positive 1. Close parentheses. What can I factor out of the second term?
7.
7, right? So positive or negative 7?
Positive.
Positive 7. I'm forcing you to say positive 7, so you write plus 7. Okay, everyone's doing this, right?
Yes.
Got it? Is it not working?
Oh, no.
Oh, okay. Times 3x squared plus 1. Okay, at this point, what do we need to do always?
Check if they're the same. Yeah.
Okay, check if they're the same. Are these two terms the same?
Yes. Right. Yes.
Yeah, so 3x squared plus 1 is a common term. If it wasn't, then we'd stop and start over, okay? So we got 3x squared. We're going to factor that guy out, plus 1, in its own parentheses. And then the first term, 3x squared plus 1 times 4x. We just open parentheses, bring 4x down. And then we have the positive 7, bring that down as well. Okay, and that's it. We're all done with number 3, okay? At this point, you should check to see if you could factor, okay? Because what are the directions? Look up here. What do the directions say? Factor what? Completely. Because sometimes you can keep factoring. Remember yesterday I talked to you about difference of squares. What if this was a difference of squares? Could we still factor?
Yeah.
Okay, but we can't anymore. That's it. We really can't factor. This is not an X box. Okay, number 4. This one's by yourself. Okay.
Binomials don't work. Continue factoring even after that instead.
Yeah, it could be, and it's up to you to figure it. 1 second. It's up to you to figure out like when you need to stop factoring. So there's no there's no directions like, oh, there's 4 times you have to factor. You have to do a GCF and an X box, or you have to do a factor by grouping, and then you have to take out a perfect square or a difference of squares. Okay. Yes.
Will there be fractions?
Fractions. When we get more advanced, then yes, we'll talk about that. But right now, we're just working with this. 5p squared plus 1, and then what? 3p plus 7?
Yeah.
Good. Okay, so you got that one by yourself, so that's good. I feel good about ending the lesson here. All right.